Welcome back, everybody. We got 2.3 while loops and string manipulations. Okay, now let's recap on our types of while loops. We've seen for loops, and we're going to introduce while loops today. The big difference is the for loop is your definite iteration, which means at the very beginning, we know exactly how many times it's going to run. It's going to start at 0, it's going to go to 10, it's going to move 1 until it gets to 10. Okay, now the while loop is a little bit different. The while loop still has a Boolean expression here that controls it, but we often don't know how many times it's going to run. It sometimes depends on the runtime to decide that. Now I put while true here, this would be an infinite loop because nothing would ever trigger it to stop, okay? And that's kind of the cool part about while loops is we can control the stop in so many different ways. Often, sometimes with game programming, we would call this kind of our event loop, right? You know, we're going to draw something to the screen, we're going to get some input from the user, and we're going to start it over again. Redraw, get input, redraw, get input, and so forth. Now, let's look at the three main types of while loops. The first one here is what we call the flag controlled. And the reason why it's called flag control is because we create a Boolean variable. And here you can see we set it equal to true so that the while loop runs for the first time. And then we look for something to stop it. Okay, so let's kind of run through this a little bit cleaner. Okay, we have the Boolean variable run, which is true, so our while loop runs. The user enters a number. I'm setting x to be a default of 0. We store their input into x, and if the number they enter is greater than 10, we set that flag, that Boolean variable, to false. So when the loop goes to restart, run is now false. Okay, so when we say flag controlled, it really means that, like, hey, we're flagging it to be false, right? But moral of the story is we have a Boolean variable that we make to, and then when we want it to end, we change its value to false. Okay. The next one is count controlled. This one is just like a for loop. You can see we have int x equals 0. We're going to go while x is less than 10. We're going to print out that value, and we're going to increment at the end of each loop. Now, if this is your style, this count controlled, I would just suggest using a for loop. Obviously, we can do it this way, but why, right? Like, just use a for loop if you have a count control. And then the last is sentinel controlled, okay? And this is a little bit different. So look at this. We have an input variable set to nothing, and we say while the input does not equal exit, okay? So this is kind of a flip here. We're saying while this is not exit. So right now it's nothing. So nothing does not equal exit. That's true. So this runs. And we ask the user stay or exit, and they input something. So as soon as the user inputs a certain thing, it'll be false, right? That's why we call it sentinel controlled, okay? Now, I've created a fourth type called forever controlled. And this is the kind of stuff that I like to do. I like to just make while loops that are set to a default of true, okay? I just put true in, and I'm going to ensure that they run. And then I put everything inside. Then I ask if they stay or exit, and I use an if statement to check for that word that I want to break out of it, kind of like the sentinel, but then I use break, okay? And the reason why I use break is a lot of times I want to send the user back. So maybe I want to use continue, or maybe I want the loop to run a quarter of the way and stop, right? If they do a certain thing. And so I like to do this way because I don't, think back here for a second. If you do the flag controlled, this means that even though I set it false here, it doesn't stop here. It's going to run all the way through to the end of the loop and then start back over and then check. So the whole loop will, its whole iteration will run. I want a little bit more control than that. So this is kind of my style here. I'm just going to call it forever controlled. Okay. All right. So let's try and do a couple while loops here. Okay. So, we have all of our basic stuff, and we're just going to do, a super simple one. Let's do the for loop one. All right. So int x is equal to 0. While x is less than 10, we're going to print out x. Okay, and then we'll increment it at the end of the loop. Okay, So let me compile this. Okay, just like a for loop, right? Now again, use a for loop for this, okay? It just makes more sense. If you know exactly how many times it's going to go, use a for loop, okay? So let's get into the ones where we get those user inputs, all right? So I'm going to make a string input. I'm going to set it equal to nothing, okay? And then in my loop, I'm going to go while input does not equal, and we're going to do the exit one, okay? Now, if you choose this sentinel controlled one, you need to make sure that you set your first variable so that this condition evaluates to true, okay? And this is the tricky part of why I don't like to use this, is because I have to like kind of trick the loop into running the first time. I can't start this off inside because I need that input variable here, right? So you have to make sure that this will at least evaluate to true one time so that this runs, okay? And there is actually another type of loop called the do while loop that kind of helps with that situation. But for now, we're gonna skip over that, okay? So I'm gonna ask the user, enter, stay or go, and I'm gonna put that into input. So just again, a reminder here, I had to create this outside because I was using it as a condition, okay? And then let's put something down here, end of the loop, so that we can see that this has to keep running, okay? Even once we meet that condition. Okay, so enter, stay, or go. I choose stay, 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 stay. So, this is where we get that indefinite iteration. It'll run as many times as we need. And then I'm going to say exit. And notice how end of the loop was printed after I said exit. So this sentinel controlled while loop means that it's going to finish the loop, okay? Even though this is where we enter into something that's going to eventually make this condition false, all right? The loop will finish, all right? This is why I like to do it a little different way. I like to go while true to ensure that it runs, and enter, stay, or go. They enter that input, and I'm going to say if their input is equal to, I guess, go. I put it as exit, my bad. I said enter, I should have said enter, stay, or exit, but whatever. And I'm going to run the break condition, okay? And let's put a little end-L here so that we don't get all those mix-ups in the lines, okay? So I compile, I run, I'm going to go stay, stay, stay. Everything's working out great, right? I type go, and notice how the end of loop line never printed out. Okay, that's kind of crucial here. I got to choose where this ended, okay? This is why I like this style, all right? You're free to choose your own style. This is the one I like, okay? All right, let's get back to our stuff here. Let's look at strings, okay? Now, I know that kind of seemed short on the while loops, so we're going to kind of bring it full circle with the while loops. But let's talk a little bit about strings. Something kind of going on behind the scenes here. Your string has always been made out of a bunch of chars, but what if we want to access those individual chars? So look at this, all right? This word, strings, okay? It has, 1, 2, 3, 4, 5, 6, 7 total characters, okay, that we can reference with an index value starting from 0 to 6, which would be a total of 7, right? Your string was never a primitive data type, okay? Remember, primitives are ints, bool, doubles, chars. Your string is a collection of chars, and we're going to get into looking at, pulling specific indexes, changing them, and so forth, okay? So if we look at this code down here, okay, watch what I do right here. When I print out, so name is our string, I've set it equal to my name, and I can call a specific index, 1. So when I say name bracket 1 bracket, look at your string, you got 0, 1. That would print out just the capital M, okay? If I do name bracket 4 bracket, then 0, 1, 2, 3, 4. The capital N would print out, okay? So that bracket is literally just called the subscript operator and allows you to access specific indexes of strings and arrays, which arrays we will get to soon, okay? So if you need to access a specific character, you can just put these brackets at the end of the string, put the appropriate index value, and it's going to print out just that character, okay? Now, one thing I always see people forget is us as human beings, we start counting from 1, but computers start counting from 0. So this space right here would be index 0. Then M would be 1, then 2, space would be 3, and so forth, okay? Now, we're going to dive into strings a little bit more even, okay? Again, string is not a primitive. String is a library, right? There's a bunch of functions written to help you work with strings, right? And I want to start diving into those so we can use them with our loops. So here we created string name is equal to, it's the same thing, but notice how I use the variable name and I go dot length. I'm calling a function, okay? And it's got empty parentheses. This will return how many characters there are, the length of the string. So, and this one starts counting at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would return the number 9, okay? Next, we have the find function. So when you call name.find, you can actually find a string within a string, okay? Now, what gets interesting about this is name.find is going to return the index number of the first letter that matches up, okay? So let's recap that. If name exists in this string, which it does, it's going to return the index of this n here because that's the start of that string. So if you wanted to find where something was in another string, you go name.find, you pass it what you want to find. If it exists, it'll return that. If it doesn't exist, you're going to see some really weird stuff print out. Okay, so be careful for that. Now, what's even super cool is that we can reassign indexes. So same thing, we have the string my name, but if I want to change the 4th index, which is really the 5th letter, right? So 0, 1, 2, 3, 4. If I go, I made a mistake, let me lowercase that n, right? I can set it equal to a char, a single char, all right? Now, this is where you have to be careful. A string is a collection of chars. So if you try to change a specific index or work with a specific index, you have to remember it's a char now, okay, when you pull that. So here I was able to change at the end, and if you reprint this out, it would print out with a lowercase n. Now, there is a term for this. There's the term mutable and immutable, okay? Immutable means it can't be changed. Mutable means it can be changed. Strings are mutable because we can change them. Okay, and then one more thing, and then we'll get back to doing some code on this, okay, is something you've probably been looking for is the getline function. This is another kind of built into C++. So getline is a string function. Well, that's not true. It's not a string function. It's a built-in function that allows us to get an entire line of input instead of just one word. So before, cin only allowed you to get a single word. Once you put a space, it got rid of everything else that was entered in. Well, we're kind of getting a little bit more advanced now. What if we need a sentence? Okay, getline is going to help us do this. We need to pass it cin and the variable we want to store it in. So here I created an empty variable because I want to store the whole sentence there. And I asked the user to enter, and then I just call getline and I pass it cin and I pass it the variable name that I wanted to store it in, and it's going to handle it. So now it should be able to take an entire sentence. Okay. Now that was a lot of new stuff. All right. So we are going to do a live code, but recap: strings have indexes. We can use a subscript operator. Strings have functionality. They have functions attached to them. Two of the most important ones so far is going to be dot length and dot find, okay? And then we can also get entire sentences. So let's try and combine that into a bunch of pieces here, okay, in our live code. Okay, so we're back to our old code here. Let's just get rid of this, all right? And I know I'm doing everything in the main function. We're supposed to make functions, but I'm trying to make this stuff a little bit more brief, all right? Let's get a sentence from the user, and let's start pulling some indexes, seeing if we could rechange them, see if we can find stuff in them. So let's go string name equals nothing, because we're just going, in fact, let's make this a little bit more clear. Let's just call it input because we're getting it from the user, okay? I'm gonna tell the user, hey bro, give me an entire sentence. Okay, wow, all right. That's where I call the function the built-in getline, okay? And I'm going to pass it cin, and I'm going to pass it the variable I want it to store it in. So cin and the variable I want it to store it in, all right? And then we're going to print this out just to make sure that it works. We're going to print out input now, okay? I'm going to put an endl on there. All right, so let's give this a compile, give it a run. So, hey bro, give me an entire sentence. I am an entire sentence. And we see that it worked, right? Name stores I am an entire sentence. Okay, now we're working somewhere. Let's test and see if we can print out certain indexes, okay? Let's just randomly print out, so we store this in the string input. Let's just print out the 10th index, okay? And let's see what happens. So I'm just, hard coding in the 10th index, okay? All right, so let's get some from the user. Hey bro, give me an entire sentence. I'm gonna put the same thing in. I am an entire sentence, okay? And look, just the character T printed out. So let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. T is the exact character we wanted to print out. Now let's see what happens if there was not enough characters. So I'm just going to go high. And look at this. All of a sudden, some weird stuff printed out, okay? One of the interesting things about C++ is sometimes we get, outputs we didn't really want because there's some low-level aspects to the language. And we have to be very careful about that, okay? If you're going to hard code in and put that I want the 10th space, you better make sure your string has 10 spaces, okay? Well, how do we make sure it has 10 spaces? Well, we have a length function now, right? So we can go and do stuff like this. If input.length, okay, which returns the length of the string, is greater than, it needs to be greater than 10, right? Then we can do this line of code, okay? And then we'll do an else function. So else, if it's not, let's just print out what the size of the string would have been. So we'll just go, oops, the string is only, and then we'll go input.length. So the string is only, 8 characters. Okay, if it wasn't 8, right? All right. So that's a lot there, okay? But I hope you're starting to kind of see that we can do some interesting stuff with these functions. We can ensure that our program works when we want it to, right? Okay, so hey bro, give me an entire sentence. I enter in high this time. Oops, the string is only 2 characters, right? So we avoided that unintended, outcome that we didn't want. Let's run it again. I am a sentence, right? Okay, we get T, it worked, right? Because we ensured that something was a certain size. This is good programming, okay? Making sure things work, okay? Now, for the last thing we're going to do here, and I'm going to delete this, or let me just comment that out, okay, is we're going to use the find, okay? So I'm going to go, let's do this. Let's just print it out. So input.find. And let's do the word M. Yeah, M. Okay, this, we're just checking, right? We're just learning this stuff. So if there's this in the sentence that the user gives in, we should get the first index of the start of this, all right? So I'm going to recompile here, rerun. Hey, bro, give me an entire sentence. So I'm going to go I am, super short, and that should be 0, 1, 2. We should get a 2 back because the A is at the second index, which you got to be careful here. It's the third character, but 0, 1, 2, right? And boom, we get a 2 back. Now watch what happens if it's not in there. I was supposed to say I am. I don't know. It's not in there, right? Look at this extravagant number, okay? So you have to be careful again. We need to make sure certain things are in if you're trying to guard against this extremely ridiculously high number, right? So you could check if this number is a super ridiculous number. If it's greater than a cajillion, then don't do anything, okay? Now, watch what happens to this. Sometimes we get unintended consequences. Let's go I ham, right? Well, that did return 1, right? Because AM was in there. Again, computers are not like you. You know the word AM, but they're just looking for those 2 characters next to each other, and they can appear in words. And now one more time, let's go I ham M, right? We still only got a 3 because it returns the first occurrence, not all of the occurrences, okay? All right, so hopefully it kind of helps you understand strings manipulation a little bit more. Let's dive into some more stuff, okay? Let's bring these together. Let's marry these loops and strings here, okay? We can do some interesting stuff now that we've learned a little bit more, right? For instance, this for loop will run to the size of whatever the string is because we set it to be I is less than sentence.length, okay? And then look at this too. We can use the for loop variable and grab a specific index every time the loop changes. All right, we can start from the beginning of the string and move through all of the strings. That's pretty important, okay? All right. Okay, so to kind of recap a little bit on this, I know this is a for loop, it's a little bit more applicable, but we're going to start trying to bring a lot of these codes together, a lot of these separate things we've been learning. Let's get them to work together. Okay, we got lower and upper. All right, this is something you're really going to need for your quick code, which we're actually going to talk about coming up here. All right, here are 4 more built-ins to the C++ language that are going to be super important. You got 2 upper and 2 lower. So 2 upper, you pass a char value that you want to uppercase, and it will return the uppercase version. That's kind of cool, right? If they type in yes with all lower cases, and you want the Y to be an uppercase for whatever reason, or for, here's a better example. A person enters in their name and they put a lowercase, and that bothers you like it bothers me. You can uppercase the first initials of their name, or you can lowercase things, right? Now I put between the parentheses, right? You need to put the char between the parentheses that you want to work with, okay? So 2 upper will uppercase a char, 2 lower will lowercase a char. Now, how do we know when to use those? Well, sometimes we need to check first. Is upper, well, you pass it a char, and it'll check if it's uppercase or not. If it is uppercase, it'll return true. If not, false. Same thing for is lower. We pass it a char. If it is lowercase, it'll return true. If it is not, it'll return false. Okay, and so you really got to think if statements for these two. You need to use these where conditions are appropriate. Okay, now just like anything, this 2 upper and 2 lower does not change the string you're working with if you pull something from a specific string unless you resave it, and we're going to talk about that. So let's do some code. Okay, so we're back here. Let's scrub this again. And let's just start with, let's start here. Let's get this sentence from the user again, and let's bring in these for loops, okay? So I'm gonna go for int I equals 0. I is less than input.length. So I want my for loop to start at the 0 index and go to the length of it, okay? And I'm gonna increment it 1. And I'm just going to print out each index on its own line so that we can prove that this works. So I'm going to go input, I'm going to pass it the variable I, I'm going to put endl, okay? So remember, I will start at 0, so I'll get the 0 index, then 1, 2, 3, 4, and so forth. So let's give this a compile and a run. Hey bro, give me an entire sentence. Here you go, okay? And you can see that it's all printed on a separate line. Here you go. Okay. All right. Let's get a little bit crazier with this. Okay. Let's check if something is uppercase or not. So if, all right, and we're going to go is upper. Now remember, you don't pass this a string, you pass this a char. Now here I know it says an int, but you got to remember that chars are kind of integers, right? And I'm going to pass it input of I. Okay. And then I'm going to go, so if is upper, input of I. All right, it's kind of a mouthful there. So let me actually recap this. So we're pulling a specific char from input, and we're going to pass that char to is upper. Is upper is going to return a true or false if it is uppercase. Okay, so uppercase will return true, it'll run. Not uppercase will return false, it won't run. So then I'm going to go, And let's go input of I is an uppercase letter. Okay. And then let's just not even run this one. Okay. So the only time something should run is when you get uppercase letters. All right. Let's give this a compile. Let me up that a little bit, give it a run. And let's do capital I am not. I am not. So there's only two uppercases. And look, I is an uppercase letter, N is an uppercase letter. So that worked, right? Okay. Let's do an else if here. Is upper, input of I, or excuse me, let's do is lower. Let's do the other one. So if it is lower, we're going to basically do the same exact thing. We're just going to say it is a lowercase. And let's change that to lowercase. Okay. Give it a compile. Give it a run. I am not amused. Okay. And we get a nice breakdown of each character and what its case is. Okay. We're getting somewhere here a little bit, right? Let's use the other two, or just one of them. Let's go, if it is an uppercase, well, that might be too much. Okay. Let's scrap this. Let's do something separately here. Okay. I don't want to give away too much for your quick code. All right. So let's do this. Okay. So we have, okay, we've been able to check if it's upper or lowercase. How do we actually change it? All right. So I'm going to scrub a lot of this. I'm just going to get a single word. I don't want a sentence anymore. So let's just do this. A word, please. Okay. And I'm not going to check. We're going to kind of guarantee certain inputs. And I'm going to then print out, I'm going to make sure the first one that they give me is an uppercase. So I'm going to print out input of 0. And I'm going to send it to upper. Okay, so I'm going to make sure the first one is lowercase. And I'm going to print out its upper version. Okay. All right, let's run this. So word please, so it needs to be lowercase, so A, please, okay. And you can see we get the number 65. Now that's probably seeming confusing, right? But you have to remember that characters are also kind of integers, and we have ASCII values. If you forgot what ASCII values are, it's each character has a number representation. The lowercase a, or no, excuse me, the uppercase A starts at 65. And then 66 is uppercase B. So we need to cast this to a char. We need to explicitly cast it to a char. Okay. Recompile, rerun. Let's do the same exact thing. And we get the uppercase A. Now, always was an uppercase A. It just was being returned to us as an integer. You can see the return type is int, and we need it as a char. Okay. Now, watch what happens when I print out the original input, okay? All right, so word please, A, please. So we get the capital A that we wanted. What's going on there? Oh, I'm now no longer getting sentences, right? Okay, let's change that back because now we're gonna need it. So getline, we'll put cin and then input. Okay, we compile, we run it, A, please, okay. And notice how this is unchanged. There's still a lowercase a there, but we just changed it to an uppercase. You grabbed it here, right? You sent it to upper, but you never resaved it back into the string. And that's where we're gonna get to that functionality. We can actually change indexes of a word. So I'm now going to sit there and go, the input of 0 is equal to, and I'm going to set it to this, okay, because we uppercased it, right? Okay. And then I'm going to print it out. All right, that's a lot there. Let's give this a compile, give it a run. A, please. And look, so here, this is the original one that we printed out on line 13 that didn't matter, right? And now I've actually changed it in the string, okay, by choosing a specific index. Now to hit on these specific indexes a little bit more, okay, it didn't have to be this complicated. So let's just, for this specific index, there's 2 upper, 2 lower, it's a little complicated, right? But let's just do, a word, okay? I'm gonna hit on this and then I think we're done. Okay. And we're going to change, let's change, so 0, 1, 2, let's change the second index, which would be the W, to be a capital W. Notice how the single quotes, because it's a char, okay? And then I'm going to change the very last one, so 0, 1, 2, 3, 4, 5. I'm going to change the lowercase d to be an uppercase D. And then we'll reprint it out. Okay. So I compile, I run, and boom, the string is now changed. They are mutable. You can change specific indexes. Okay. All right. Let's get back to this. All right. So let's talk about your quick code. All right. This one is, I think it's fun. All right. So number 1, create a SpongeBob Mocky meme generator. Obviously text only. It's not going to have pictures. Now the SpongeBob Mocky meme generator, as you can see, is, someone says, don't use the weird SpongeBob Mocky meme, and then they get mocked, right? But text-wise, and it's really just a combination of upper and lowercase letters, okay? Now, this combination doesn't really seem to have too much of an order. Sometimes you see an upper, 2 lower, an upper, lower, upper, lower, lower, lower. It's just madness, okay? And that's all right. We're going to make a little bit of system. So your program should take in a sentence from the user and mock it back to them like SpongeBob, all right? Now for this part, you should think of a for loop going through that string, making some changes to it, okay? Upper and lower. So this means every other character will be an upper or a lowercase, okay? So it would be like capital D, lowercase o, capital N, lowercase t, and so forth, okay? All right. You can assume the user will enter in all lowercase, okay? Now, what I mean by that is, if you don't want to take the advanced opportunity, then just every time you run your program, only put in lowercase, okay? Now, there's an advanced opportunity if you want to allow the user to enter in uppercases in their sentences and still have it work properly. So, for instance, they entered in something crazy like this, and it still went upper, lower, upper, lower, upper, lower, upper, lower, okay? That would be an advanced opportunity. The other opportunity you have to think about is the space here. A space is considered a character, so you might want to try and find a way to ignore the spaces, or just see what weirdness prints out, okay? And now the third part is the user should have the option of running the program over and over again until the user decides to quit. Think while loop. All of this should be in a while loop, okay? And that while loop is going to run it over and over again. So after they get mocked, ask them, do you want to be mocked again? Okay. Or, and then they go yes or no, and then they get to go back to the beginning. If they say no, then the program ends. Okay. Now I didn't put any stipulations on functions, but I do expect for you to separate things into functions where you can. Maybe your while loop calls the mocking function, right? And then when the mocking function ends, it goes back to your while loop where it then asks if they want to end or something like that. Okay, but there should be functions in this. All right. Okay, so let's go and look at your quick code example. All right, so here's an example of what your quick code should look like. So, it starts off, obviously, you probably want more of an introduction. Enter a sentence to be mocked. Please do not mock me. Okay. And you see that we get back, please do not mock me, right? Just like SpongeBob would. Now, I thought a lot about this, and you can see that the order kind of gets messed up after the spaces. And I wrote a lot of code to take care of that. And then I decided it was a little bit too advanced, okay? If you want to give it a go for it, but it won't be required that the order carries over spaces or punctuation. Okay, and I'll show you punctuation in the next one. Would you like to be mocked again? Yes, I would. So enter in a sentence to be mocked, and watch. I'm going to go, please don't mock me. And it ignores it just fine, which is great, but the order gets a little bit messed up there, and that's going to be okay. And then I answer no, and suit yourself. Okay. Now I'm going to, I have no problem telling you some of the structures that I'm using here. I use a for loop for this. Okay. I use a while loop to repeat the code. I have one additional function. I literally call it the mock function. Okay. And then, one additional function outside of main. Okay. So there's not too many structures here, but I will tell you one little thing. I know in the couple previous lessons, I haven't been doing the clearing and ignoring for the cin buffer. And in order to get this to work, you most likely will need that tool again. So keep that in the back of your mind, okay? If you forgot about that, go and check out the 1.3 video, and hopefully you'll remember because you're going to need it, okay? All right, everyone. It's a long one. Enjoy. I'll see you guys next time.